coursing through a solitary existence. But slowly, their gentility turns to rage. They grow larger and larger, curling and twisting and desperately reaching down from the sky. And what began as an invisible shade has turned into a monster. Tornadoes are powerful, spinning columns of air that stretch from the ground to the clouds. Most are relatively weak, but the few that grow into large events are extremely violent and cause immense destruction. Tornadoes occur on 6 of the 7 continents. The country with the most tornadoes based on land size is the United Kingdom, with an average of about 33 tornadoes reported each year. But the country with the greatest overall number of tornadoes and the most intense is the United States, with over 1,000 reported annually. Tornadoes, no matter where they occur, are classified as either supercell tornadoes, which form within supercells, the most powerful class of thunderstorms, or non-supercell tornadoes, which are smaller and weaker and form within non-supercell storms. There are many theories surrounding the formation of tornadoes. One key component they share is the presence of both high and low pressure air in a given space. Air particles from the area of high pressure move toward an area of low pressure, a movement that creates wind. Non-supercell tornadoes, such as waterspouts and landspouts, begin when cool, high-pressure air and warm, low-pressure air are present, particularly near ground level. As air particles move horizontally from the high-pressure area to the low-pressure area, wind begins to pick up. Winds blowing at different speeds and in different directions and altitudes begin to blow cyclically. In the case of non-supercell tornadoes, they turn into an upright spinning vortex. But to create supercell tornadoes, the circumstances are slightly different. Violent supercell storms draw warm, low-pressure air up to a higher altitude, leaving behind cool, high-pressure air near the ground. Bubbling and boiling thousands of miles beneath the surface and just waiting to burst through. Volcanoes are scattered across the planet. About 1,500 active volcanoes can be found across the world, though countless others are on the ocean floor. Most volcanoes, whether on land or underwater, are located where tectonic plates meet. In fact, the Ring of Fire, a path that traces the boundaries between several tectonic plates around the Pacific Ocean, contains about 75% of the planet's volcanoes. There are several types of volcanoes, primarily classified by shape and size. Major types include stratovolcanoes, which often appear as tall, steep mountains; shield volcanoes, which are flatter and dome-shaped; calderas, which are large depressions in the ground; and mid-ocean ridges, which are underwater chains of volcanic mountains. No matter their shape or size, all volcanoes emit gas and molten rock. The journey of these emissions begins deep underground in the Earth's core. The core, which can burn as hot as the surface of the sun, transfers its heat to the surrounding rocky mantle. In doing so, the heat melts some of the rock. This molten rock, or magma, is lighter than the surrounding solid rock layer, so it rises through the mantle. The magma then escapes through vents in the Earth's crust, causing volcanic eruptions. Now above ground, this magma is referred to as lava, and it can reach temperatures of over 2,000 degrees Fahrenheit. In addition to lava, volcanoes may erupt with searing hot gas formed in the mantle. In a phenomenon called pyroclastic flow, This gas, combined with hot ash, can race down the sides of a volcano as fast as 100 miles per hour, burning everything in its path. To measure and classify eruptions, scientists developed the Volcanic Explosivity Index, or VEI. It considers various factors such as the volume of lava, gas, and other emissions from the volcano, along with the height of the eruption cloud above the volcano's summit. The VEI scale begins at 0. Each successive measurement increases logarithmically, meaning that each magnitude is 10 times more powerful than the one before it. The VEI scale does not have an upper limit, but every mountain range and every chasm on its face is a scar, with many telling a story of when the Earth rumbled to life. Earthquakes occur around the world. They've been recorded on all 7 continents, but most quakes take place in just 3 regions. The Mid-Atlantic Ridge, an underwater line that runs down the Atlantic Ocean, the Alpine Belt, which stretches from the Mediterranean to Southeast Asia, and the Circum-Pacific Belt, which traces along the edges of the Pacific Ocean and is where about 80% of all earthquakes occur. These areas experience the most earthquakes due to what lies beneath the surface. Earthquakes are the result of pressure, specifically pressure caused by extreme stress in the Earth's crust. That stress can be caused by volcanic activity or even man-made activities in certain areas. However, most earthquake-inducing stress is caused by the movement of tectonic plates. Tectonic plates are constantly moving, either against, away, along, or underneath each other. But sometimes their edges may catch and stick. The plates, however, continue to move, or at least attempt to. Energy from this attempted movement builds around the edge's sticking point, creating immense pressure until the edges are forced to let go and the plates slip. This causes a sudden and powerful release of energy, so powerful that it breaks the Earth's crust. This fracturing emits shock waves through the ground and causes intense vibrations, or quakes. In fact, the world's most earthquake-prone regions are where the most geologically active plates meet. Earthquakes, or any seismic activity, are recorded by seismographs. When the ground shakes, seismographs oscillate, drawing a jagged line to reflect this movement. The more extreme the earthquake, the greater the height of the jagged line. These recorded motions are then used to measure the earthquake's strength, or magnitude. While several scales of magnitude exist, the one seismologists prefer is the moment magnitude scale. It has no upper limit, and it measures earthquakes logarithmically. This means that each magnitude on its scale is 10 times greater than the one before it. Unlike the now rarely used Richter scale, the moment magnitude scale can be applied globally and can measure quakes of the highest magnitudes. They rumble. Rolling across the land, they darken the skies to then spark fire in the darkness, letting out an unmistakable roar. Thunderstorms are rain showers accompanied by lightning and thunder. While violent, these weather phenomena are common, with about 2,000 occurring at any moment worldwide. There are 4 major types of thunderstorms: single cell, which are small, weak, and isolated storms; multi-cell, a common type of storm that includes a cluster of thunderstorms; squall line, a collection of storms that can form a line hundreds of miles long; and supercells, the most intense kind of storm capable of producing tornadoes. All thunderstorms form when warm air in the lowest layers of the atmosphere rises. Called an updraft, this air causes water from the Earth's surface to evaporate, and carries the moisture upward to form clouds. The clouds then build and grow, sometimes as tall as 10 miles high. The clouds darken as they fill and become heavy with water. Cool, dry air from the upper layers of the atmosphere, known as a downdraft, then pull this moisture downward, causing it to fall as life-sustaining rain. In addition to helping sustain life, thunderstorms also help maintain the planet's balance of energy and electricity. When energy, specifically in the form of heat, causes water to evaporate, the heat is carried upward with a water vapor. As the vapor condenses and forms water droplets, it releases the heat into the higher altitudes of the atmosphere and cools the Earth's surface. Thunderstorms also help regulate the electrical balance between the atmosphere and the planet. As clouds in a thunderstorm develop, excess positive and negative charges form within them. At a certain point, this buildup of opposite charges leads to the transfer of electrons in the form of lightning. This transference of electricity occurs so quickly that it breaks the sound barrier, a phenomenon that produces thunder. While thunderstorms are necessary for maintaining balance in the atmosphere, they can also be hazardous. Lightning strikes create fires. Excessive rainfall can cause flash flooding, and high-speed winds from tornadoes can destroy homes. Meteorologists